Make sure the door is open so the students could get in here. Yep, controls. Yeah, they can get in here. Maybe trying to give me that. I can't get in because you didn't try. Quick access. Yes, you can get in here.
Mm-hmm.
All right. Now, timer. They got about 3 hot minutes.
Tyler, you got everybody wanting to be in space.
Everybody want to be in space.
It's a matter of more people.
Yeah, you got everybody wanting to be in
Must be
space
talking
too.
about Jalen.
It's a matter of people.
It's a natural thing, yeah. It's the
Hey,
Crab
hey,
Nebula.
hey, Jalen, where you at? Jalen, you Mars, Jupiter, where you at?
No, I don't know. I guess they should say Mars. That probably the next Earth anyway.
Look all right up there, man. Don't look too bad. I might come visit you, man.
Okay, you're early. You get extra credit, Jalen. All right. Valdez gets extra credit. He's early too. Okay, so Valdez is present. Stucky's present. Welcome to class, Shamar.
What's up, Tyler?
Not much, sir. Welcome to class, Miss Kennard. Okay, Mr. Garcia's just arrived. Mr. Gray is here.
How you doing, Mr. Tyler?
All right, sir. Okay, so we have 5 more minutes. I'm gonna give everybody to get into class. See, somebody else just popped up. Who's this? Aaliyah. Okay. Mims. Okay. All right, so use this time to set your screens up. We're gonna, in a moment, start our norms and also begin working on today's assignment. So one screen should be your Google Doc. Another screen should be your Etsy portal. Let's put this here. All right, 4 minutes. It's getting cold outside. It's getting cold outside. It'll be 20 degrees to 25 degrees tonight. 3 minutes. If you're on a cell phone, you have to download the Google Doc app. All right. See if anybody else has arrived. I think all the names are saved. Start processing it. So to get us started while we're waiting on everybody else, you just want to make sure. I want to wait before we start our norms. You want to make sure that you have one screen. When I say resize, is of course your ESI portal. You're gonna need a simulator. I'll put this in the chat right now. You got to load this up because we got to make a screenshot. So go ahead and put this in one of your windows that you have resized. Let me put this in the chat for you. There's 2 snapshots we got to make today, so we'll talk about that after the norms. But I definitely want to give you this in advance so you can already open it up and have it running. So when we come to that part, because we're going to do our document first, set it up. Then we're going to put the pictures in because that usually gives people a hard time. I want to do that first. Do our problem. And if there's any questions, yeah, Daj is supposed to come in. What do you mean? She's supposed to be able to come in. She's trying. She's probably doing it from a new device. There you go, Daj. Says you was trying to get in here. Welcome to class. We was just about to start our norms and stuff. Where's her name at? There it is. Okay, so we don't have Perry. Smith is absent. Autumn's not here yet. Sinkhaire's not here yet. Mr. Miller, I gotta reach out to him. Not here. Gray is here. Garcia is here. Edward Dooling, that's another one. Jeez, still a student of the month and he disappeared. Courtney is not here. Jamar Davis is absent. Latrell Champagne, that's someone else. That's like falling off. Not here. Bailey, not here. Archie, she was here yesterday. I think that's everybody. Everybody else is pretty much present. If I didn't call your name, Valdez, Stuckey. Yeah, I'm looking at the names.
Mr. Tyler,
Yes, Miss Moore.
you saw my message on ASP?
Your message? Oh, yeah. I'm gonna take care of that tonight. I didn't get a chance to respond to you. Sorry about that.
Okay.
Okay. And then you just got to tell me those things because I do remember they said they was doing start testing, so I'll fix it tonight. Where was that at? 16 seconds before we begin. So let me send this to the office. This is everybody that's gonna be here. And we can get this work done. Everybody should look for the assignment in EDSB. It's dated for December 1st, today, right? Okay, so our norms. Sorry, I had a little bit of ginger ale. It's got my throat all clear but gaseous. All right, now 5 basic norms. If I start at the top of the list, that'll be, of course, Miss Mims. Leah, can you read number 1?
No one has the right to hurt another person.
Thank you. Alexis, can you read number 2?
Education in the classroom are sacred.
Thank you, sir. Daje, number 3.
We will never behave in a way that discredit ourselves or squad family.
Thank you, Miss Moore. Stuckey, number 4.
Accept canvas of students over the lady of gender.
Thank you. Mr. Gray, can you read number 5? Jarrell, you there?
You said number 5?
Yes, sir.
Take pride of it. So Academy Southwest.
Awesome. The 5 academic norms. Mr. Garcia, can you read number 1?
It said respect the opinions of others.
Thank you, sir. Miss Kennard, yeah, can you read number 2?
We respect the culture of the class. The cultures of the classroom.
Thank you, Ms. Kennard. Mr. Davis, number 3.
We are attentive and participate.
Thank you, sir. Coming back to Miss Mims, number 4. Aaliyah, are you there?
We have high expectations for ourselves, our peers, and our teachers.
Thank you, Aaliyah. Alexis, can you finish off with number 5?
We're here to focus on preparing ourselves for post-secondary endeavors.
Thank you, sir. Okay, so everybody, let's get this done. Put this work in. Well, in this case, we're talking about electricity in terms of electrical potential energy. So there's potential energy that you get from just working out, moving around. Oh, wait, let me slow down. Autumn, I just saw a big old A on the screen. And Champagne has arrived too. Okay, let me come back to attendance. They made it. So the simulator, let me put this back in the chat because you're gonna need to boot that up or start it up at least and have it ready so you can keep up with the taking the snapshots, right? For one, and then 2, putting the snapshots into Google Docs. You need your Google Docs open, you need your ESB open, and you need that simulator open. Well, I'm trying to log attendance for Champagne and Hall. All right. Okay, it's saved. Now, back to this. So we are done with our norms. Let's go through what today's agenda is about. And that's in the ESB message, right? So if you're in ESB, you'll see the assignment that I gave for today. So I'm going to come here and grab this statement because I want to have a student read it. So I'm going to do it this way because I always have trouble when I do it the other way. I'm going to take just this part, and someone can get 10 points for just reading this part. Hold on. Put this in there.
I will.
Okay, we'll go right ahead. You see it? Oh, Garcia, you can get the question next. Let her read that part. I just saw your hand. So,
hello, all future electrical engineers. Asynchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow as class as well.
Very good. That's 10 points for Leah. Mr. Garcia, did you have a question or did you want to read next? Which one was it?
I want to read.
Okay. I just wanted to be sure. All right, so I'm gonna put the next part in, and I want you to read the question that we're gonna do together. Our synchronous problem, everybody. And I'm gonna be giving you notes on this. So Garcia, whenever you're ready, start with 1S. And that's for 20 points. So take your time reading it slowly.
You said the 1S?
Yes, sir.
A uniform electric field is established by connecting the plates of a parallel plate compactor to a 12-volt battery. A, if the plates have a separation of 0.75 centimeters, what is the magnitude of the electric field in the compactor? B, capacitor. A charge of plus 6.27 times 10 to the negative 6 power. Columbus moves from the positive plate to the negative plate. Find the charge in electric energy for this charge. I don't know.
So find a change. You got it. You got the points. Pretty good. You power through it. So the capacitors we're talking about, they usually keep a reservoir of energy, and we're going to see what that's about in this simulator. So let me put the simulator back in here again, and there'll be another opportunity to read more. But let's get the simulator out the way, and then we're going to go back to our document, and we'll get the rest of the questions in the document. So first thing is first, let me grab that link. And what you want is, of course, this, let me blow this up for you. You want this screen to be showing. So I'm going to put the link in there in the chat for you. And everybody click on the link and get it open so you can get ready to do as I do. We got to take 2 pictures. So 2 screenshots, basically. You should see a pop-up. Welcome to class, Sherrod. Let me mark him. Oh, he left. Okay, he just was here. All right, so click on the link, you guys. And first one we're going to work on is capacitance. This is what Garcia was just missing with the capacitor, right? So the same thing is true here. We're going to see what a capacitor is.
And any capacitor is usually just two plates, and they're depending upon how far apart they are, is how much energy you get. So you don't really need to have anything in between it. It's just the conductivity of it is based upon electromagnetic energy. So let's come over here, click on capacitance once you have that loaded. And what I want you to do is recreate this situation. Okay, now how do I do this? So I'm going to restart everything because this is last period I did with students. Move this out the way too. So I'm going to reset everything. And then what I want to do is first, I want to, okay, it was a hand raised. I saw Garcia. Go ahead.
Yeah, I was asking. I joined on my computer. You could repeat the link in there.
Oh, sure. 1 second. Y'all getting the hang of that raised hand feature. It's pretty cool. Let's copy this. You can put your hand down though, Josh. Thank you. It stays up there, so I don't want to get confused later. All right, did you see the link?
Yeah, I do appreciate it.
Okay. So everybody, all I want you to do is first give it some battery power. You come over here to the battery, right? And you just grab this slider and bring it up to 1.5 as a maximum. Now, if you want to, you can see that if you change the polarity or you go down and change the battery upside down. If you go up, it changes it to the top, right? So I wanted maximum positive voltage, and you have these plus and minus charges over each plate. Now I want you to spread your plate area. I want it to be a little larger because you see, the larger the plates, the more capacitance. So if I make the plate smaller, you don't have much capacitance. Now this stands for 0.59 picofarad. That's how capacitors are measured. Capacitors help your system from blowing out. Like if you have a thunderstorm, the capacitors store the energy and they surge it back so it doesn't blow up everything in your house. Next, I want you to turn on the top plate charge and the store energy values. Okay, all these should be on. So we're gonna go for maximum plate value, and then the separation, you'll notice the maximum amount is when the plates are very close together. Now, how are they creating energy? There's an electric field. We talked about the electric field yesterday in our do now. So I'm gonna turn on the electric field and you'll see the electric field lines, they point downward. So here's a cycle. Current, when we talked about Ohm's law, I think, current goes all the way around in this cycle. Now, if I disengage, this turns into a battery. The energy doesn't go anywhere. So that's something important to note. So what I want you to do is take a snapshot of this. Don't forget our voltage thing. We need to see how much is on this plate. Take the red and connect it to the red, and take the black and connect it to the bottom plate here. Okay. And as you can see, without it being connected to anything, it still has about 1.5 volts. Now you guys are going to need to, and I can increase the voltage if I want it, right? By just bringing the plates down. And then let's see how much they got now. So if I do this, remember it was more energy the other way around. So that's because they lost some energy. So I can change it and see what it is, and it's way less now. Okay. So what your snapshot has to be is this. See how I have it set up and everything? You're going to come over here and click on FET and then do screenshot. Okay. Hold on, everybody. Synchira. Okay. I gotta do 10. So take a moment, everybody, and do this part. You should have your screen set up like this. And when you're ready, take a screenshot. Welcome to class, Synchira. Are you there? I think I see your name. Perry's back. Okay.
Hey, Mr. Tyler.
You just made it. I'm gonna put this link in the chat for you so you can catch up with us. Right now, we're working on capacitors and how they're set up. Give me one moment, everybody.
Okay.
Sorry about
So once we got it all right there, we just screenshot and send it to you.
No, not send it to me. I put it in your Google Doc. Okay, so
And just put it in a Google Doc. That's it.
but we still got a problem to do too. That's not it. We got a lot to do. So First, screenshot it, and then create your Google Doc and put that screenshot in the Google Doc. But you need your title, you need your
How do you
header.
take a screenshot again?
Say what?
How you take a screenshot again?
You come over here to FET. You see here in the corner. I'm clicking on that. It's a FET button in the corner. Okay, I think he got it. All right, so now that's our first screenshot. If you did like I did, you hit this and then you go to screenshot and you take a screenshot. Now let's establish our Google Doc, right? So you make sure we're in Gmail. And of course, make sure you're the correct account that you're going to use. Google Apps, and then Docs. If you're on a phone, you have to download Docs to keep up with us, right? And you have to send your snapshots. Try to put your snapshots inside of the document. A little bit tricky to do on the phone, I know that much. So open the blank document. And then we have the basics, right? We got to set up our document title. This is what we always do. So do now. Dash. Everybody should be creating this right now so you can have it already just done for share outs. So do now and then dash. The date, today's the 1st of December. Next, you need your header. So I'm typing my name, but you should be typing yours. 1st of December 2020. Period is 5th, and it's intro to engineering with robotics. Today's title, I'm just going to tell you what it is because we don't have a whole lot of time. We got to get the simulation picture in there, and we got to get all the notes. It's a lot of stuff. All right. So what is today's title? It is basically, you see it right there, plates at different potentials. Okay. You should have this much typed up with me. And don't forget to, already have your stuff screenshotted and ready, because we're going to insert it into this document now. Okay, so I'm going to put this in the center. And so I'll give this a little bit of res, a little bigger. So you should have this much with me, right? Next, our exit slip. And that is composed of our classroom term of the day. And the word of the day is, oh, what could that be? Well, for one, the word of the day, I know from Townhouse and GGI, was infer, right? Here, it's going to tell you what it is in brackets inside of EDSB. So if we look at that, that's electric potential energy. All right, so we type that in, and that's the definitions you have to look up. All right, so far so good. Now we got to grab both questions so we can start solving it. And then we're going to put our screenshot in there. So let's grab the questions from EDSB. The first question was what? We had it read by Mr. Garcia a moment ago. So I'm going to grab that one right here. The next question, grab it as well. 2A is your homework problem. Now, again, asynchronous problems, you have opportunity to still, come on Thursdays, because those are asynchronous days for robotics students, to it's like office hours, to get caught up on any asynchronous problem or any problem that you think you're falling behind on. So, if you're going to have to come a day, trust Thursday is the best day to try to catch up on things. Let's see here. So I got both questions in the document, and this is what you should have so far, right? Now this is the part, there we're going to put our screenshots in here. So let me just come up a little bit, and I'm going to just go to insert, image, upload from my computer. Now, this is after you screenshot it and you set up your simulation already, everybody. Okay, so it opens up a menu, and I'm going to take this and I'm plug it in. Cool. Next, I need a screenshot of the light bulb. So I'm going to go back, because remember, there's 2 screenshots we need. I'm going to go back, and if you look here, there's the light bulb. We did capacitance first. Now we're going to do the one with the light bulb. Okay, hope everybody's following. So I got this picture done and put into my document. I'm going to click on this one now. And what I want to do is I want to turn this light bulb on, right? So in this position, it's disengaged. If everybody wants a full section, because now we're about to power it. Okay, so first step is connecting it, right? And you see the plates are supercharged and they're ready. All these settings have to be on too, and you need this measurement device. So we want to know how much energy is coming off of the actual light bulb, right? So I'm gonna put one on top plate, the red, the black on the bottom plate. So it's 1.5, it's measured nice. And then I just want you to see what happens for the voltage when we disengage it and connect it to the light bulb. So let's do that. The plate's charged. It has a lot of plus and negative charge points. And then we'll come over here and connect it. And then once connected, boom, you see the voltage and the light going down, as well as this graph. Now, your goal is going to be to get a snapshot of this when it's brightest, has the most energy, before the plates are dissipated and the charge is gone. Because once this plate is charged up, it acts like a battery, but a battery, it doesn't keep charge. It goes through and it gets used. It's not cycling. It's just gone. Okay, so I'm going to connect this again and show you what you need a picture of. And I'll show you how fast you got to do it. So make sure you have this connected the same way I have it connected, and the battery's up, and all these are selected so you can see everything. Next, once you connect the light bulb, come over here real quickly and click on the screenshot. All right, so let me show you what I'm doing. So I'm going over here, I'm going to click on it, boom, the light is going, and I'm clicking on screenshot, and I got a snapshot that I need to put in my document. You have to do the same. All right, so let me come back to the document and put that in there. So this goes right here. Did it put a question or did it put the picture? Oh, okay. Let's undo that. I think it didn't do it. I did it wrong. Okay, so it's insert, right? I'm trying to paste and it's insert. Follow your own rules. Insert image and then upload computer, right? That's what we did last time. And boom. Where are we at? This is this one here, right? And here's my second one. So I got both of these, and that's how it looks, right? And that's how quick I had to go. I had to come over to Fed, click on it to get that bright. Let's see how bright you can get yours, though, with the same connections, and the voltage has to be changing, so if you connected it right. Okay, so I'm done with that. Now it's time for the initial notes to today's problem. Excuse me. So let's see here. If I am thinking about this correctly, this problem is just done. I'm just giving y'all a minute to get caught up.
We skipped that one in the second problem.
You said the second problem, what, dear?
The second image. The second screenshot, do we stick it in the second problem?
The same problem type?
The screenshot that we just took, do we put it on the second problem?
No. You can put that. You can put those images all the way at the bottom, Ms. Canary. You can put them wherever, as long as you have them. Okay. As long as you got both of them, you're fine. You don't have to put it with. I know what you're saying. You don't have to put them with certain problems. You just need that because that's your simulation part of your grade. All right. The problem, though, I was looking that up for you. You're going to need some initial notes. I'm trying to see if I can pull the notes to make this easy on everybody today. Where's my drive at? Recent, because I didn't mean to close that other one out. Okay, what about this? Yay. Okay. So let's blow this up. And we got all this done. So here's some initial notes you're going to need. Okay. You're going to need the equation for electric potential and electric field. And it's a lot of calculations involved. So I'm going to give you just the initial steps on the screen, and I'm going to put it into the chat for you. So here it is. Let's see how much. I think I'll put that there. Okay. These are some initial notes. And I'm about to start feeding into the chat real quick. Hope it all fits. It looks like it did. Yeah. So just to reiterate, equation for the connection between the electric field and the electric potential, those are the plates, right? So you saw the electric field in the middle. Those are those arrows. Let me go back to the simulation so you can see that. Those are those arrows in between the plates here, right? So you see these little arrows as they expand and they die out. Let's do this again. That's your electric field, basically. So I got it all charged up. Now watch what happens. You see it pulses and it loses the electric field and loses charges too. So that's what this is talking about there. So that's the potential. And then your electric field, there's an equation for it so we can calculate it. This is what we're calculating. I want you to visually, that's why we did the simulation. I want you to visually see what the electric field was in terms of capacitors. It's there. And you use it all the time, especially with your, I don't know if you're aware, your cell phone chargers, they have capacitors in there, right? They have adapters that fluctuate the electric field. So E is equal to the E field, the negative change in electric potential divided by the distance. Voltage is what electric field, voltage per, or voltage divided by meters, is how you measure electric field. Voltage is, or changing up electric potential is just voltage. And distance is always meters in this case. So the mathematical representation of such is E is equal to minus parentheses, and change in simply means delta. That's a mathematical Greek symbol that just means that's what it does. Final minus initial. Okay, so change in, let's recap. This means in words, change in the second equation, right? This part here is the second equation you need. So change in potential energy, that's the delta PE, is equal to, matching it up for you guys, the amount of charge, that's Q, multiplied by the change in electric potential. And that's going to be your delta V there. Okay, so now that we have all that said, here's a mathematical version, and here's how they're measured. Now it's time for our known and unknowns. So let's do that. And again, you got to make sure you center your notes here like I have. You should have just as much done. We've done the pictures and they're down there, but we got to keep going and just work it out. So this has two parts, this problem. So let's take it slowly as we try to solve it. So the next set of notes will be, let me grab them for you. And you got to edit the same way because there's some values that have subscripts or superscripts. So just make sure you do it the same way. So here we go. I'm going to put this on the screen and then you can edit it so it looks correct. Because when you put it in the chat, it's not going to be right. Please don't be a copy paster and you don't fix what you copy and paste it. It takes points off. All right, so here's the next set, right? Your known values. I got this from the problem. Let me put this in the chat for you. Okay. You see in the chat, it's like 1 with a 10 minus 6. That's not 10 minus 6 coulombs. That's 10 raised to the negative 6 power. And you have to edit it like we've been doing since the start of the quarter. Please do that. So where did I get this stuff from? Well, if I scroll up to the top to the problem, it says it's a 12-volt battery. It gets a minus 12 automatically because of the direction of the E field. Okay. And it already is going to be converted or designated differently due to the equation having a negative in there already. So that's going to be delta V. That's your voltage, 12 volts, right? It's 12 volts minus 12 volts is going to be your change in voltage. Then your distance was in the problem said to be 0.75 centimeters. Centimeters cannot be used because remember, we only calculate distance in terms of meters. So we had to convert it. When you convert centa, it just means 10 to the minus 2, right? Raised to the negative second power. If you look in the chat, it says 10 minus 2 meters, and that's not right. So you got to raise that to the minus 2. So I told you there's places in there you got to fix this so it looks right on your paper or your document. Now, Q is given in part B. That was plus 6.27 times 10 to negative 6 coulombs. In part A, we calculate the E field. In part B, we just get the change in the potential energy, delta PE. Remember, delta T is always change in. Okay, we talked about all that in our initial notes to do the problem, in case you forgot. All right, so what is the first part? Part A, how do we do it? Okay, well, grab this and put it on the screen so you can see it. Like I said, I could have took you painfully through all this, but you know, I want you.
Please do. Please do.
I can't do it. There's not enough time. But Thursdays, you should have your behind there, so I can. You can't stop time though. So, because we still got other parts to do. So, like I said, on Thursdays we can re-talk about these things or whatever the case may be. But right now, it's just compliancy, making sure you get your notes and you get it typed up so you can submit it. All right. Where we at? So this is part A. I gotta put this in the chat for you guys. Right now, it's just getting it formatted correctly. That's the next set of notes. Yeah, I'm not being evil, but I'm treating you all like you are adults. It's time for real world training. All right, so I want to put part B in there because there's a lot of stuff to do, but I want to give you time to edit everything you just seen. So it's 3:14. I want to give you about 5 minutes to get caught up, and then we'll put part B in there. If we got questions, we'll talk about them. But you got to understand, I think 2A is similar, and I was just going to give you tips on how to start it off. Not do it for you, but show you how to start it off. And like I said, I think I said this already like a broken record. It's going to be Thursdays where you have asynchronous. It's like office hours. So you know you need help with something. First, figure out what your questions are, then come to the table because there's going to be other students probably asking questions in that session as well. And it's only an hour or so itself as well. So where are we at? So the timer, how much time can I give them? Approximately 5 more minutes. You have to, once you get it from the chat, make sure you cross out the right dimensions. All you're doing right now is just making your paper almost identical to mine's on the screen. You just take this time to edit it correctly, cross out the right things. While you guys are doing that 5 minutes part, I'm going to put part B in there real quick, just in case I got some people that's already done with that. So part B, you have to calculate the final answer, and then the problem is done. You can use Math Papa to do it. I suggest it because there's a lot of raising stuff to a power in that final step. So here's the final steps. And those final steps look like this on the screen. If you want to know what you got to fix. Okay. Just make sure you cross out the right things. And remember, it's not 10 minus 6. It's 10 raised to the negative 6 power. To calculate this, you could use Math Papa. But you notice the final answer is not calculated. You all have to do that. Hopefully you get the right answer using it. You type it in slow with the parentheses like I have in this above step. You don't have to put the plus in there, but you can put this part 6.27 times 10 to the negative 6 power times negative 12 in Math Papa, and it should give you the correct answer. So in about 2 more minutes, we're gonna discuss how to set up part A. I'm sorry, the homework problem. Take you through what you could do to get it done quickly, and then we should have time for questions. Yeah, I just wanted to show you how similar the problem is. If you got the notes for the first problem, the second problem are way easy because you kind of already know what to do if you follow the steps. Okay, so I think we're ready for a 2A, right? And everybody should have calculated that final answer. So 2A is right here. And what do we use to calculate this? Well, it's the same exact problem. The values just changed. That's it. So we use the same notes, right? Scroll up here and grab it. And what we can use is now our known and unknowns will change, right? So that we can't just use that again. But this part right here, yeah, that's can be used again. So just copy that to 2A. Okay. There. And then what? Our known and unknown values, we got to change it a little bit. Not a lot, but a little bit to the values that are in the problem. So I hope you're paying attention because I'm trying to help you out with the homework problem now. So I'm gonna grab this. This is from 1S, but I'm gonna show you what changes, right? So let's put that there. And let's see, is it still 12 volts? Well, yes, it is. Is the separation of the plates, is it still, what were they? 75? No, now it is 0.65. So let's change that. At least showing you. And I want you to be doing this because, you know, you should get used to it. All right, so we fixed that part. What about the charge in part B? Well, it's not the same number as before. Now it is 5.47. This is the homework problem, everybody. So we're going to change that to 5.47. Next, we need to set up the problem in our part A and part B. So let's do part A together. And then I want you to do part B. So part A, I want you to do some of this. And we got to change the values in here, right? Because this is not 7.5 anymore. I took this from the above problem. I'm just showing you this is a practice problem. It's literally the same steps, just different numbers. Duh, right? So let's say it's not 7.5, it's 6.5, I think, right? Change that. People be telling me I like using paper. Okay, that's great. But with a computer, you can just put things where they are if you've already typed them before. So you got to calculate the new electric field E for part B. And for part, yeah, we need it for part B, but for this asynchronous homework problem. And then once you do that, you still got to go and do this here for delta PE, right? So that's part B in these steps. And I'm gonna give you guys about 5 more minutes to work on this, and then we're gonna do share outs and get ready to dismiss for today because I want to get your in-class points. So we did a lot. I even got to the point where we can talk about the homework problem. I think we're productive today. Okay, so that's part B. And again, you got to change this because in part B, it's not going to be what? It's not going to be this 6.27, right? We got a new charge amount of 5.47. So you just go through 5.47. Fix your notes up. Okay. So I think I did a whole lot for y'all. Now, you got to try to get it all done, okay? So 5 more minutes, and then we're going to do share outs. Does everybody understand what I just did to get the homework problem almost done for y'all? Because it's not done. You still got to calculate those last parts with the question marks.
You finna put it in the chat or like that was something we had doing on?
I'll be nice this time. I'll put it in the chat.
Oh, okay.
Okay, so this is, I don't want nobody getting confused. What I'm putting in here goes with the homework problem. Don't get confused. So it goes under 2A. You should have put that other part above under 2A as well because that's the prior notes. So you got to edit the same way I did. That's for, your new homework problem, known and unknown values. Part A. Let's come here. You got to make sure you cross out the right things again, right? Part B. Again, make sure you cross out the right things. You edit it correctly. Okay. So Friday's quiz should not be hard on you all if you got these great notes. And you have them in chat transcripts, and the videos will be available later on today. All right, so I promised 5. Did I start the clock? I did, didn't I? Yeah, I did. Okay. So in about less than 4 minutes, we're going to do share outs, and it's just to see how far you've gotten or what you've gotten done. If I were you, I'd be getting all these notes into the document because once we leave the room, it takes a little bit before it shows up. I think around 4:30, you'll be able to see the chat room notes, and you'll be able to see the video.
Mr. Tyler, you can look at my message on SB.
1 minute. Let me see here. You solved it. Is that okay? I think.
I was trying to make sure that's the right, like I was doing it the right way. 'Cause I'm still confused.
You talking about which one are you calculating?
That was B. That was the second problem.
So the second problem, part B. Is that what you're saying, Garcia?
Yeah, that's what I'm saying.
Okay, so did you use Math Papa for it?
Yeah.
Okay, let's see here. Let's see if you got it. If you did, I can give you the points for it. So let's side by side this Joker.
Are we sharing out?
If are you ready to share it? Let me type this in here and see if I got it right. That must be Valdez. He's ready to go. So let's hear. That is parentheses, right? 5.47 times 10. Hold shift. We're gonna raise that by pressing 6 to the -6 power over 1 close parentheses times. That's a -12, right? So yeah, I think. Hold on. I think you got it. Let me look here. I think you did it right. Not exactly, but it was a good shot. That's what you should have typed in, though. Okay, so let's do share outs. Let's see here. We turn the feature on for you all.
Can I share out?
Valdez, then you, because he asked first. So give me 1 moment.
Bro, what class is that?
Say what? Okay, there we go. All right. So go ahead, Mr. Valdez. You should have the floor now. And I'm gonna start presenting. Okay, so it's on you now. Sorry, in class points section. And then Daje is next. Okay, so you're presenting. Okay. Oh, I gotta turn this off. 1 second, Valdez. Shush, shush, shush. Okay. All right. Okay. Hold down. Yeah. And you got your images. Okay. Cool. All right. So so just submit it via SB. I see your hands up, Garcia. What's your question? You're pretty good, Valdez. You got your points. You can leave in 5 minutes.
I want to present.
Yeah, you'll be right after Daje. She's next. Okay. So Daje, are you ready, or you go ahead and then I saw a hand up by Kennard. So you want to go after Garcia? I don't know if that's what you was doing. So we waiting on Daje first.
All right, I'm finna show
I
up.
think Jarrell
My
went
picture and nothing not in here yet, so don't be expecting to see my picture, Mr. Tyler.
You got to submit it by tonight, okay? So, okay.
Oh yeah, and I need the exit slip, the words of the day.
Okay. So I'm gonna put that in the chat for you guys, and you can stop sharing. You got your points. You really got a lot done. Exit slip. Who was next? I think it was Garcia, right?
How am I supposed to turn it off?
How to stop?
Never mind.
Oh, stop presenting. Yeah, girl. All right, I'll put this in the chat for you. There we go. Let's see here. So who is next? I think it was Garcia. There he is. Okay. Dude, you getting better, mister. I don't know what I'm doing. See? Oh, goodness. This takes time. Uh-huh. Great job. Okay. Okay. And you got the pictures. I said, what about your pictures? Okay. Now, don't forget at the very top, your exit slip. You got to tell me, okay, now you see how I did it? Infer doesn't go there. You got to bring it down some. Yeah. And then just type in what it means, its definition. And then the other one I put in the chat is electric potential energy. So you got to find the definitions of 2 words. But great job overall. You got your points. You can stop presenting. I'm sorry, y'all. I forgot which hands were up next. I think it was. Who was it? I think it was Jalen. I think it was Kennard. I think it was Kennard actually. Was it? Ms. Kennard, did you want to go next? Was that the order? Because I remember a hand going up.
I never raised my hand. I guess it was a Jalen boy.
Okay. Okay. So Jalen, what about you?
What happened?
Are you ready to present?
No, not yet.
Okay.
I gotta
Well,
do my
let's
thing.
go around the room.
Tyler.
Yes. Who's that? Latrell?
Yeah.
What's going on?
I had left the class. My Wi-Fi went out. Can you send a video to me so I can get what I missed? But I got part A and part B. I just need let me see.
The video.
I just need like the beginning and stuff. You feel me?
Okay. Well, I'll send that to you.
I got it.
Put it in SB. All right. So mute yourself, Latrell and Daja. You still talking? Mute yourselves.
I'm not even gonna click it.
I'm like, who is she talking to? Okay. All right. So who is it? Autumn. You have anything? Sherrod, what about you guys? She's smiling and screaming. So what have you been doing, dude? Oh, Gray. Okay. Okay. Oh, he got a lot done. All right, scroll down. Did you get your picture? Oh, okay. You did get your simulation going. All right. You got to take the snapshots and put it into your document, Gray. So you turn it in.
Okay.
All right. Perry, what about you, dude? Like you should have done something. You done nothing the whole class, huh?
Sir, understand that I'm a little slow.
No, you ain't slow. Nice try, kiddo.
I got you though. I'll work tonight, so I'll probably work on it.
Right, baby.
I'll go next, Tyler.
Oh, go ahead. Go ahead. These are in-class points. You guys can't opt out of not getting these points. They hurt your score. Okay. Sinkara, you present. There she is. Okay. Okay. You keeping up. Mm-hmm. Oh, you got a lot in there. And did you get the homework? Yeah, you got some of the homework too. All right. You just make sure you calculate all your final answers and get your exit slip in there. Pretty good.
Okay.
Let's see here. I think Autumn, I didn't see.
I could leave.
Yeah, 3:35. Those who shared can leave. If you shared.
Yeah, I got a question.
You said what?
For the electric
Y'all be
potential
so hyped to leave.
electric potential energy, do I put the equation, like the formula, or like the definition?
You put the that's a great question. You put the actual definition, not the equation. Okay. Who else? If you've already shared, you're free to go. I marked your points down. I can count who's done what here. Latrell, you're just gonna have to wait for me to send you the video so you can get caught up. If you have anything you can share, you can share for points. So, Shamar, what about you? Was you able to get anything started?
Yeah, I got my doctor stuff done. I can send it to you on SB or something. How that gonna work? Cause I got it done. But
Okay. But you can't share, right? Okay, that's Kennard. Pretty good. So just send it to me through Edsby, Shamar. Put it in Edsby's assignment, not a message, but in the assignment. Miss Kennard, great job. So everybody, make sure you download the PDF and put it into browse your computer, put it into the assignment. You're done, Miss Kennard. Great job. Like you got all the stuff. Let's see who's next. So okay,
What's the word of the day?
The word of the day was in the chat. Where did I put it?
It's not. It didn't finish the whole.
Infer.
Oh, okay.
Mm-hmm.
I said irrelevant. I meant to say infer.
So who's sharing next? We had 3 more minutes of class. It seems like Autumn left, but she's still here. Alexis, you're free to go. The people I haven't seen. There's Autumn.
Deuces.
Okay. Waiting to see your work. I see that you're connecting or broadcasting.
Okay, she's switching screens. No, that's environmental science. Okay. Oh, you got the image in there and everything. Pretty good. And the notes. Okay. You just gotta clean it up a little bit. All right. Yeah, you got a lot done. Did you get the homework part? It look like that's the first part. Oh, okay. There's your exit slip part. Okay. All right. You got your in class point.
Yeah, my computer died. That's why I'm in here twice. My computer had died, and I had to hurry up and switch over to my phone.
Okay. Okay. All right. Well, try to get turned in Autumn by tonight by 8.
Okay.
Not to me. Let me ask. Are you in class?
Yeah. Hold on. I'm finna sign out now. Hold on.
Okay. Like, oh wow. So I have who's left. What about you, Aaliyah? Was you able to get anything accomplished?
I don't know how to do well, the picture thing that we supposed to be putting in.
Mm-hmm.
I don't know. I'm confused on that one. Like, I'm lost.
How you lost? What happened?
Like, I know how to screenshot, but like, what we supposed to be screenshot? Like, what we supposed to be doing?
So that part was real quickly. You got 2 snapshots, right? If you see, let me show you my screen. Everybody else is free to go. If you have no questions, I'm gonna help her out with that, and that'll be the end of class because it's 3:39. So, Aaliyah, you see what I'm doing?
Yeah.
All right. So the first screenshot you needed was remember everybody that's leaving 8 p.m. is when this is due.
How you do that with the strings on the little thing right there?
You talking about this? You talking about these probes?
No, I don't know.
The electric field lines?
Yeah.
So you click on electric field there. You see that?
It's not doing it.
Okay. Can you share your screen and show me what it's not doing?
All right, hold on. Can you see it?
Yeah, it's coming up. Okay. All right. So first, you didn't even turn the battery up, dear.
How you turn the battery up?
Click that dial, drag it up. All right. Nothing happened. What happened with your stuff? So do me a favor, reset that because it seems like it's stuck. Oh, I see what's going on with you. You don't have it connected. There you go. Now it's connected. Electric field. Now turn up the battery. There you go.
Oh, okay.
Now when you drag it over to turn the light bulb on, it'll it'll dissipate. It'll lose the energy. So yeah, you can put your probes on there. One on the top plate and one on the bottom. Make sure it touches the plate. Yeah. So make sure it touches exactly the plate. That's good. Now connect it to the bulb and you gotta take your picture. You gotta be quick. Oh, don't forget you got those 2 selections, top plate and store energy. You turn those on. There you go. Now, once you connect that to the light bulb, you gotta go over there and hit screenshot. You're not ready yet. First, you gotta connect it. Then you gotta hurry up and do screenshot. So
how
move that out.
It?
I'm about to tell you how. Yeah, move that over. Leave that there. Now you see those locks, like those circular poles.
Right here.
Drag it over to where it's connecting to the light bulb. Yeah, other way. There you go. Boom. Now hurry up. Screenshot. 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 Ah, that's a bogus picture. All right, you're supposed to screenshot faster than that, little lady.
My bad.
Okay, so try it again. But that's the first one. Now, do you want me to show you how to do the other one, or you got it?
Show me how to do the other one.
All right, so that's light bulb. You need to get it when the bulb is bright. Okay, so try it again when you get a chance. Go to capacitance, that other one.
This one?
It says capacitance. You see the little house at the bottom?
Oh.
Yeah. Okay. Now, again, give it some battery power. All right. Turn on your electric field. Click on electric field so you can see it. And don't forget top plate charge and store energy. Turn those on. Okay. Now reconnect reconnect it. One on top. The red is on top. Black is on bottom. Great job. Now, I want you to just disengage the locks from the battery so it sits by itself. There you go, like that. Now, you take a screenshot of that. So 2 screenshots, one that you did with the bulb when you get the bulb bright enough, and that one. Put them both into your document.
All right.
All right. You're free to go. It's 3:43.
You want me to share my what's called?
You share your document that you've been working on?
Yeah.
Sure, so I can get your in-class points.
Can you see it?
No, you didn't switch the screen to it. I'm just looking at your simulation now. You're trying to show me your Google Doc, right?
Yeah.
Okay. There you go. Okay, yeah, I can see it now. All right, don't forget to center your notes and
I gotta put the second question.
and all the notes in.
And work on it.
Okay. All right. Okay, so you got your in-class points. Try to get it all done by 8, Aaliyah, and I'll see you in class tomorrow.
All right.
All right. I think that is it, Mr. Rush.
Hey Tyler, Aaliyah just starting to come to this class, like, cause I looking on